9:15. Now the topic for the day is kind of the design principles. So what is a design principle? Um, First of all, we'd answer this question. A design principle can be considered as a statement. It is a statement or a theory which advises or which tells us the best practices to follow, best practices to follow when developing uh, a solution for an application, for example, for an application. So anyone want to help me? Excuse me. Yeah. So anyone want to share your thoughts here? For example, if you talk about the design principles, we have so many design principles available. For example, the drive principle, and then the solid design principles. Anyone want to share your thoughts? Can you please share your thoughts, please? Amay, Gautam, Revant, Umang, anyone? If you have, whether you remember it correct or we don't mind here, just share whatever you know, whatever you remember. And, you can even Google and open the page, and also you can explain. It's not a question, it's not an interview, please. It's experience, sharing your experience here. Not just the people like Amay, Umang and all. Anyone can Google and try to explore. And can I have some volunteer to share your thoughts here? Mm,
Yeah, with respect to dry, I would like to share my experience.
yes.
Yeah, so in one of the project that I was working on previously,
Mm,
so code base was quite big enough. So what the problem that we initially faced was due to the line number of lines of code in that particular project was big.
mm,
uh, we also found that there were a lot of things. So let's say in the utility packages or in that side of classes,
mm,
which are generally uh, used for utility as a library or as a methods, whatever it might be. So what we found out that there were a lot of those methods which were actually duplicates. Duplicate in the sense their logics were kind of duplicates. However, the method signature and all those might vary a bit, but
mm.
more or less the logics, what the method is supposed to do, was duplicate. So going through each one of them it becomes tedious when they are specifically used in various parts of the project. So yeah, that is with respect to dry that uh, basically we should avoid writing uh, twice. Means we should not repeat whatever we have written.
Yes, absolutely correct, Mike. You want to still continue, or you're done? Uh,
Yeah, and
Thank you so much. So, anyone else, please? You want to share your experience? Yeah, the drive principle. It's a full form for something called as don't repeat yourself. Okay, don't repeat yourself. This is a principle which states that we should not repeat our code multiple times. Repeating the code multiple times, the drawback is if you want to make changes to the code which is repeated across multiple locations. Let's say one piece of code is repeated across 5 locations, and if we want to change that code, we have to make changes across 5 places. So, for example, that's the problem. Maintenance is the trouble if you repeat the code. Usually I take this from the basic example, kind of the hello world example. Let's say we want to use a class that that expresses the greetings on a specific occasion. For example, um, we have the birthday greetings, public, class, happy birthday. Okay, after explaining this, basic example, I will talk about some other example. For now, I'm taking a basic example. So we have the birthday class, and then we have the public class, and let's say New Year. Okay, public class. We want to express the greetings on the eve of the New Year, and then we want to express the greetings on the eve of the anniversary. uh, okay, some kind of so in these classes we want to express the greetings of the respective message. For example, public void uh, uh, greet birthday, and then kind of some message. Okay, so print um, the, let's say, some message related to the greet occasion, something like this one. And then in here we look at the same kind of code but with a different message. Let's say we have some kind of code. Okay, so and once again similarly we have another method in here. Let me copy and paste this one. Okay, so happy wedding anniversary, whatever anniversary you talk about. Okay, here it is, great anniversary. Now in all these three classes, if you look at the forget about the example here, the focus is on the concept. Okay, it does not really feel like real time or working example, but realistic example. But the focus is on the attention has to be on the concept here. If you look at this one, we have the birthday message, we have the New Year message, and we have the anniversary message. And so can I have you people answer me my question? So before wishing a particular any person with the with this one or with this one or with this one, what prefix or what suffix we usually prepend or append to this message prior to the actual message of this one or this one or this one? I hope you understood my question. My question is, before we greet a person on a specific occasion, what prefix or what suffix we append or prepend to these greeting messages? Anyone, please?
I guess happy is the prefix.
Happy, yeah. Happy is common in all. Thank you, Alfia Khan. But even more, if you want to think even more beyond this thinking, um, yeah, Alfia Khan or anyone else, please. Let's say we wish them in the morning. What will we do prior to this message or to all of these messages? Or if you are making a wish in the evening, or if you're making a wish in the afternoon, what is that we do?
Hello, hi kind of message.
Exactly, yes. So even more elaborating means thank you, or let's say public void uh, greet morning kind of thing, right? So and then what we do, system dot out dot println, and then okay, um, hello, and then good morning. Okay, and then do you think, all of you please, do you think that this message has to be common across irrespective of the occasion of the greeting? Yes or no? Please answer me, all of you. Are you able to understand my?
Yes,
Yeah,
it is
thank you.
repeating.
It is repeating, and is it a required message? Generally speaking, do we have to wish them with this message prior to the actual location? Yes or no, all of you, please. We greet them, right? So hello, good morning, and then the actual location. So what is happening in all these three cases? Uh, aren't we repeating the code hello good morning code? So that's what we are repeating there. So if you want to make changes to the message that is hello good morning to something called as hello good evening or good afternoon, in across how many places we have to change this one, please?
All the three places.
All the three places, correct. Yeah, thank you, Alpiakan. So here, this is the so-called maintenance trouble. So when we repeat our code across multiple places, as for the easy understanding, I have made use of the fundamental example, but this can be applied to the any realistic example as well. So what is the fix for this one is, can anyone want to correct the fix for this one, please? Does anyone want to provide a fix for this one? So the trouble in this, I guess, have you all understood the problem statement if you're repeating the code? I want to make a change to the common message, which is currently talking about good morning. At a later time, I want to change that morning to evening. I will have to change it across 3 or 4 occurrences wherever it has occurred. That is the problem statement. Can all of you please raise your hand symbol if you have understood the problem statement? Yes, thank you all. Now, I'm clear of your response, all of you. Can all of you please now, uh, suggest me the fix? How can we overcome this problem of, uh, you know, code up repeated multiple places? What is the solution for this one?
Yes, sir, by using inheritance, we can do.
Inheritance. Thank you. Also, so here what we do is we take this common code and we put it in one parent class. Okay, public class. Okay, general message or general message, and then kind of this one, and then inside here we put this message. Okay, public void greet prefix, greet prefix or something, and then we take this method code and then place it in here, and then we remove this one. So this is kind of the already known topic to you people. Inheritance, you already know that. I had already explained in my core Java classes. Inheritance helps in avoiding the code repetition. And then once we are done in this case, and then what we do is we make all these classes extends the general message, and then so usually these class names are okay, so extends the general message, and then so this is another one, and then this is another one, okay, kind of thing. So now we have made a fix to the problem statement that if you want to make changes to code, we will change it to across only one problem. So this is called the principle don't repeat yourself. The principle acronym dry, and its full form is don't repeat yourself. Problem statement of don't repeat yourself is if we repeat our code across multiple places, and if you want to make changes to that repeated code, you have to make changes across wherever it occurs, and then chances are there while making changes here and there, we will forget 1 or 2 places where we have to make changes, and that will break the entire application code. Okay, so that's the problem and solution about the don't repeat yourself example. Okay, now if you want to make any changes, you can just change here good afternoon, good morning, or something like that one. Now the general example, application specific example can be kind of the let's say you are working with some Hibernate programming, or you're working with some normal classic JDBC programming. So when we work with classic JDBC programming, for example, customer management is the module that is common across any business. Whether you talk about the IRCTC application, or whether you talk about the online shopping portal application, or whether you talk about the Book My Show application, most of the application, banking application, so multiple applications, the customer management is the common thing, wherein we want to develop the customer management, such as customer ID, customer other details like customer first name, last name, email address, registering the customer, sending SMS, okay, sending email alerts, whatever things are there. So across multiple applications, the customer management module is mostly common. In all these cases, we can use the common code in one place. Okay. Another example, if I want to talk about, is kind of the employee and contract employee, permanent employee, which I explained you in the core Java sessions. Actually, I hate the word core Java. I call it as Java Standard Edition. So in Java Standard Edition, when I talked about the inheritance, I used a few examples like employee class is there, and then we have the two types of employments, kind of contract employee, and then let's say permanent employee. We have the concept of permanent employee. This way I want to. So here in this case, for example, consider we don't have the employee class, and the one I had used some time ago in my core Java classes. Okay, public class contract employee is there, and then we have the concept of public class permanent employee. So in both the classes, we have kind of let's say public void. This was the example that I explained you. Calculate net salary, and in order to calculate the net salary, both the contract employee and the permanent employee classes need some information like how many days an employee is present, and what is the actual salary per month for him or her. Okay, public void calculate net salary. Okay, calculate net salary kind of. So before, in order to calculate, we need the attendance, the number of days he or she has attended, and we need the gross salary, and then we need the deductions. We need the deductions, and then finally net salary. Net salary is equal to let's say gross salary minus deductions is what we actually need. So in order to calculate the gross salary, what we require is we require the attendance as well as the actual. For example, so these lines of this is the formula we generally make use of in order to calculate the net salary. So if I copy this one, it is there in the contract employee class as well. Now, in this case, in order to calculate the gross salary, for example, we require, so let's say this one has kind of, private int attendance. This variable implies this, contains the number of days an employee attended, the number of days an employee attended. Okay, so kind of this one. So, and then we have something called as the private double. Okay, gross salary. Private gross salary is equal to some 10,000. Something is there, for example, and then let's say we'll talk it about as monthly salary. Monthly salary, the actually agreed salary. This is about the actually agreed salary. So no, the actual agreed salary, the actual agreed salary. And then what I need here is I will write one method to calculate the gross salary, public double gross salary. So in order to calculate the gross salary, what I first of all do is I will calculate the per day salary. Double per day salary is equal to monthly salary. Okay, monthly salary divided by 30 days, for example, if you can count the per month salary per day. And then okay, double gross salary is equal to, okay, double, don't get confused with the method name and the variable name being same here. It is syntactically possible. Okay, so here double gross salary is equal to let's say gross salary is equal to days attended. Okay, attendance, okay, multiplied by per day salary, and then return, and then this is the gross salary, and then let's say this is how we get these things, and then return gross salary, kind of. So in this space, when it comes to the calculate net salary, so here, in order to calculate the net salary, what we do is double net salary. Double net salary is equal to get gross salary. So this method we are taking, get gross salary. This method is what it is calling this. So this method will return the calculated, and we get the gross salary minus deductions. For example, if you have the deductions like double deductions is equal to, you know, oh, deductions is equal to we let's say some 10% of the salary. So I'm not using any formula for now. So deductions is equal to this one, and then here system dot out dot println, and then net salary is equal to, okay, and then plus, okay, net salary kind of. So if in this case, if you want to calculate the net salary for the, this is the case of the contract employee, and then let's say we want to do the calculation for the permanent employee also. In permanent employee also, in order to calculate the net salary, we again need the gross salary, which is the per day salary, the gross salary. This one is there. And then when it comes to the deductions, in case of the full-time employer, the permanent employee, we have something called as the income tax, for example, something I'm taking, and then we are taking, PF as kind of, some 200. It varies, PF and all these things vary. Okay, and then we have, we have something called as the gratuity, for example, 100, and then we have something called as the insurance. Okay, you see, insurance is equal to, for example, 300, and then, okay, and then double deductions. Deductions is equal to, let's say we take all of them into one place. So income tax plus PF plus gratuity plus insurance, and then this is the okay, double net salary. Excuse me. Net salary is equal to, sorry, some throat irritation and I'm disturbed. Okay, so some net salary is equal to gross salary. So here also I'll make a call to the get gross salary method. Get gross salary method, and then the deductions. So this is the deductions. Excuse me. Now here, in both these cases, we have this piece of code which is commonly spread across, these two types of employee classes. If at all in future we want to change this formula to something else, of course, not necessarily all the times, then we have to make change in both the contract employee class as well as the permanent employee class. Since this is a fundamental, basic level of code, it might look simple that, oh, it just has 2 lines of code. Is it that trouble to change this 2 lines of code? If at all we want to change that, we should not think that way. Think in big. Okay, so we have 100 lines of code, and you have to, out of 100 lines of code, you want to make changes to at least 60 lines of code here and there. So chances are pretty much high that you will make correct changes in one place, you will make incorrect changes in other place. So that's the trouble if we repeat the code across multiple places, and whenever you want to make changes, you will. So to overcome such thing, what we do is we put this common code into one place, which is the parent class. And usually I explain the difference between abstract class and interface, what is the role of MS class kind of thing. And then what we do is we cut and paste this one inside the parent class, and we make these classes extends the employee class, and then similarly, so we make we cut this one, and it's no more in here, and then we take extends employee. So when, if you want to make changes to the formula, you can just go ahead and make changes to the parent class. So this is the explanation of the don't repeat yourself. Although it looks familiar, like we have been using inheritance and all these concepts, the goal of this conversation, this interaction, is about understanding the principle of DR. So I have tried to explain DRY, its problem statement and its solution. All of you, please raise your hand symbol if you understood the entire interaction. Yes, thank you all. And yeah, so anyone want to share your thoughts, something in here? Anyone, please? Can that be? Do you think that can be improved, or do you want one more example I explain, or is that all fine? Amay Revant, I think you have come up with your. Is that okay? Revant, Gautam, Umang, is that okay, or you want to say something on that?
No, it is good. It is good.
Thank you, Umang. And the people. Anyone, please? Yeah. So yeah, Gautam, you're trying to say something.
No, it is good.
Okay, thank you, Revant.
Yeah, Ravi, it's fine.
Other people, Deepak, Nikita, Pallavi, Sonu,
Yeah, it is good.
Yeah, Ravi, it's good.
Yeah.
It's going good.
Thank you all. So that's how it, drive principle. This topic is about design principles. We actually follow all these principles while developing the code. Okay, that's how that's about the drive principle. Now let me talk about the uh, next topic. For example, uh, another principle called as the um, encapsulation principle, please. I think this is the of familiar example concept to everyone. The another principle is something called as encapsulate um, for changes, encapsulate for changes, or otherwise some people call it as encapsulate what that is changed, what that is changed frequently. Okay, uh, you can even call with another term encapsulate that varies. All these are one and same, please. Interchangeable statement names. And encapsulation, I told you if you remember some time ago. So encapsulation is the process of abstracting. Everyone knows this one now. The very first fundamental principle of object-oriented programming system. Oops. So encapsulation is the process uh, is is the process of binding, or packing or combining, whatever you want to call it as, binding or packing or combining data and code into one unit. So this is what encapsulation we usually think. But encapsulate for changes, it's kind of the same thing with little modification of this one. But actually this one is, for example, you have the encapsulation called employee class, or employee class is there, and inside the employee class you make a variable public integer employee ID, and then you have the classes like employee class main. Okay, public employee main one. And this is the class, the program which I explained you in my code Java classes. And then let's say we have the employee E1 is equal to new employee, and then E1 dot employee ID is equal to 100. And let's say you have some 4 to 5 classes like employee main 1 2 3 4 5. And let's say this is the case, we have employee main 1 and 2. And since the main classes are directly making use of the employee ID variable name by using the object, in future if we come across and make changes to the employee ID variable name to employee code, okay, then what will happen is this when we make a change here, we have to make a change here as well, because when we make this variable name here, this all these main classes 1 2 and 3 will break from working. So this is the trouble if we make things public. If we make things public, which we usually gets changed once in a while or frequently, depending upon the business requirement changes. So that's the problem if you make the things public. And the problem is, if you want to make changes, whatever changes we make will break across multiple places, okay, wherever it has scattered. and that won't be the nice approach. So in order to do problem or overcome such problem statements, we put all those things as private, which are frequently changed or which are changed once in a while. And if you make something as private, the calling classes like main 1, 2, and 3 cannot make them. So in order to give access to these classes, we provide getters and setters, as we all know. I'm not typing any code here, so getters and setters. But the conclusion here is encapsulation is actually not restricted only to the variables such as the instance variables. It can also be applied to the methods. There are times where we apply the private keyword to methods also. For example, we have the method called as void. Okay, calculate benefits. Okay, calculate uh, benefits. To this calculate benefits, this calculate benefits contains the performance appraisal related logic. For example, the performance appraisal related logic is not the method that is actually required by main 1, 2, and 3. These classes, these outside classes need not be aware that there is a method called as calculate benefits. Okay, so such methods, this calculate benefits method currently takes argument 1. In future we want to add argument 2 and argument 3, and and in future we want to delete the argument 3. Kind of this keeps on changing the number of arguments, the logic inside the method, etc. So if you make this method as public, and this method is exposed for public access, and the other classes try to execute this method, whenever you want to make these changes, like removing the arguments or adding extra arguments and changing the internal business logic, etc., the code will kind of break. So for that reason, we make some methods also public, private, so that this is encapsulated. This is the meaning of encapsulate what varies or encapsulate what changes, and this is a simple explanation. Of course, if you listen it for the first time, this will be kind of interesting, but if you, because you already know this one, I don't know what's your impression on this one. Is that possibly it is the impression kind of, it's as simple as that? I don't know. So all of you, please raise your hand symbol whether you understood this one. Encapsulate principle, all of you, please. There is no rule that encapsulation is applied restricted only for variables, nothing as such, please. Okay, so this has to be noted. So thank you all, clear of your response. Okay, so please be noted, there are some times where we encapsulate the methods also. A very important point to remember, please. So that's about the encapsulate what changes. And then if you talk about the next principle, give me a minute, please. Sorry, some throat irritation, sorry. So this is the encapsulate what changes, and let's move on to the next principle. Kind of the next topic is the solid principles. We call them as solid design principles. And solid full form is it has something like single responsibility principle. And these O stands for open closed principle. And of course we don't use suffix, but that's okay. Open closed principle, and then something called as Liskov substitution okay, substitution principle, and then another one is called as the interface interface segregation principle. And then we have something called as the dependency uh, no abstraction, okay, dependency abstraction, or we can have use some other name. These are the different meanings, expanded forms of the solid. S stands for single responsibility, O stands for open closed, L stands for Liskov substitution principle, and then I stands for interface segregation, D stands for dependency abstraction. Now let's understand the uh, meaning of all these principles. Okay, so here before I take and talk about these things, anyone want to share your thoughts here again? Um, your experience here among Deepak, Amay, Alfia Khan, Pallavi, anyone please? Mm. Did you come across these things or did you use them already? Anyone want to share your experience once again here as you did previously? Hello. The first principle is the what you call it as single responsibility principle. So let me continue my version of this explanation. Single responsibility principle. If you take the concept of single responsibility principle, I'll take this one here. So this principle states this principle states that a class should contain a single responsibility, class person in single responsibility, and there should be only one reason, only one reason um, for changing the code in a class. Okay, if you look at the definition of the single responsibility principle um, in the internet, across different websites and for blogs, you will see slightly different sentence. Um, a class should contain a single authoritative, kind of definition, which is a little high level, but the meaning of that, whatever definition you look at, this one is kind of, this one is here. So here, consider you have let's say you have a class, a user registration system. For example, when you're developing a web application, and then usually any user who wants to interact with that web application, he or she has to first of all sign up. Is the call is the sign up with the website, like providing the user email ID, password, first name, last name, and mobile number for verification and all this. So this process we call it as user registration process. And let's say you have a class called public class, you have a class called public class user registration, and inside the user registration you have the registration process, for example, okay, public void register, public void register. Inside the register method, you write the code, okay, code here to store the user details in the database, such as or we inside this particular piece of code we make use of the service code, like user service, and user service will internally make a call to the user DAO. Okay, and user DAO internally contains the JDBC code or Hibernate code, whatever code applicable, that stores the database, the user details in the database. And once the user details are stored in the database, for example, during the user registration process, usually one step that we come across is we want to So for example, this one is currently making use of the JDBC code, classic JDBC code. If you remember, in order to store data in the database in Java applications, we can use the classic JDBC programming. Classic JDBC programming, what does that mean? Classic JDBC programming means wherein we have to manually load the driver class, such as driver class dot for name. Of course, I told you from Java version 1.6 onwards, loading the driver class is optional explicitly because it is automatically loaded. So loading the driver class, establishing a connection, and then creating a statement such as prepared statement, and then calling the method such as prepared statement dot execute update. So all these statements we have to do it manually. But if you make use of Hibernate, what will happen is we know the meaning of Hibernate. It generates much of the JDBC code automatically. All we have to do is provide the details in configuration files such as the Hibernate configuration file, or otherwise the persistence.xml. And in addition to that, we have to provide something called as the mapping information called Hibernate mapping and all that stuff. So if you make use of Hibernate, much of the JDBC code that we will otherwise have to type manually is looked after by softwares like Hibernate. And if you take even more advanced approach, Spring Data JPA, it's even more advanced than classic Hibernate. So so as the technology improves, a lot of work that is done by the developer is automatically generated. So for example, the next improvement from classic JDBC is we have the ORM like Hibernate. We have ORM like Hibernate, and there are other tools as I explained. And then we have next improvement to Hibernate is Spring Data JPA, kind of this. So here, in order to perform the registration process, we need to communicate with the database. In order to communicate with the database, we can go for one of these three possible approaches. Consider currently at the time of developing this user registration class, in this particular, we are using the classic JDBC. And after storing the details of the user inside the database, let's say the user registration process also involves something called as the validation of the email ID and the mobile number that he or she has provided with the system, because that can be possibly a spam email ID, or that can be a spam mobile number, or that can be a bot or whatever which is trying to register with the website. So here, to do that, what we'll do is a public void verify email. Okay, you have something called as a method called as verify email method is there. So, and this contains email. Okay, so code to verify verify the email. And similarly have the method to verify public void verify a mobile number. Something is in here is there. So code to verify the mobile, code to verify the mobile number. So here these two methods, what they are doing as per the name, they're explaining that they contain the code that verifies the email, which means sends an email notification and asks the user to verify whether the email is correct or not, and something like that, which is also similar to the mobile. But in this entire class of the user registration, if you keenly focus on this one, this class has two responsibilities. Responsibility number one is registering the user. Registering the user is kind of storing the user details in the database. Okay, this is responsibility number one. And the responsibility number two is we have two let's say, please do not misunderstand, please do not wrongly understand that one method has one responsibility. It is nothing like that. It's not that one method is one responsibility. Please don't focus your attention like one method is equal to one, nothing as such, please. So this is one responsibility wherein the business functionality of storing the user details inside the database. It is one responsibility, and verifying the user detail, email ID and mobile is another responsibility. So these two methods together is one more responsibility. So this class has two responsibilities altogether, and the focus is what I'm trying to explain here is in future, currently this register method is making use of the classic JDBC. In future, you want to switch this classic JDBC to Hibernate. Then even though you are making modification only to this particular register method, you have to compile this entire business logic, which is another responsibility. That means you should not come and make changes to this class. You should not come and make changes to this class regarding this responsibility. Currently, this email verification has currently the code that is sending emails to using the email server such as SMTP server such as server number 1 or Gmail, for example. Later, this email notification logic has to be changed to some other server such as Yahoo or something else, for example. Then what will happen? So even though you are changing this one, which is not at all related to this business logic, you have to change this one. So whether you require a change here, whether you require a change here, the entire code has to be compiled. And once again, please do not consider this single class with 3 methods alone. Please consider huge. Please consider huge. What I'm trying to say here is, let's say this one is currently we are saying that this is one responsibility, this is another responsibility, and let's say this is currently developed with consideration of the Gmail server as the email validation server, and in future you want to switch from Gmail to something else, for example, then you have to change it here. As I'm telling you, please do not imagine this single class. Consider this class depends on some other class, and that some other class depends on one more other class, and that one more, the third class depends on the fourth class depends on fifth class. So there is a lot of interlink between a bunch of classes. That means if you make changes to one of the classes, all the interlinked classes will affect. That means all of them have to compile, all of them have to be unit tested. A bunch of things will happen. So don't ever imagine, don't ever play your attention, focus your attention with only this particular 3 lines of code or 10 lines of code. Always imagine in bulk when you're trying to understand the concept here. You can come and say, Ravi, what is the problem if I want to change this one? It's a matter of 10 lines of code that I can compile. What is the trouble? It's not that way of thinking. Please imagine this user registration is linked to something else, and that one is linked to something else, and so on. And each of the classes that user registration is linked with, that is linked with a bunch of unit testing like JUnit classes, and that is again linked with something else, Mockito. There's so many things to talk about. So wherein if you want to come and change the code inside one class because of one reason, the entire dependent classes will be changed and will be affected. So the problem here is, don't put your class, don't put too many responsibilities on this class. For example, you cut off these 2 times and then put it in another class called as public. Okay, public, and then public class, okay, validate credentials. Okay, validate credentials kind of thing. Inside this class, you put your validation verifying email, and then verify not credentials, which is not the suitable one. Validate contact details. Validate contact details is the suitable class name for this one. So now this class has a single responsibility. This class has a single responsibility. If at all you want to change the code logic inside the validation, this change will not affect the code that is there inside this registration process. And if at all you want to change from JDBC to Hibernate, that change will not affect this. So this class might depend and be linked or connected with 5 classes. And the 5 classes that are linked, the interdependent of this class, will not be affected if you make change to this one, and vice versa. If you make changes here, the number of classes that are linked for this one are not affected here. So that's about the single responsibility principle, problem statement, and the description and the meaning. Single responsibility, as per the definition, it states that a class should contain a single responsibility, and there should be only one reason for changing a class. So if at all you want to change this one, the only reason is you want to switch to Hibernate, you want to switch to Spring Data JPA. So that's about the single responsibility principle. I have tried my best to explain you the problem statement and solution and meaning. All of you, please raise your hands if you understood that. Yes, thank you all. Clear of your response. Anyone want to say something that it can be improved? Anyone, please? Revant, Gautam, Amay, Mang, Alfiakon, Nikita, Pallavi. Anyone want to say that? Can the explanation still be improved, or did that go well, or how is that?
It's going
It is
good.
good,
Ravi.
Ravi. It is good. Yeah.
Thank you, Umang and Alfia Khan. Yeah. So that's how, single responsibility principle states. Okay. So if you look at my explanation, I explained you near about 5 to 10 minutes of this particular point. But if you look at the self-learning of this principle in internet, you might come across this kind of statement and this kind of thing, but chances are there your understanding is limited to only these 10 lines of code, which is actually not the case to be. So that's about the single responsibility principle. And the next one we want to talk about is something called as the open closed principle, open closed principle. So according to this open closed principle, the statement is kind of a class should be open for extension. A class should be open for extension, but closed for modification. But closed for modification. This is another interesting, very beautiful topic. Okay, so this one, let's say we have we have a class called public class. You have something, notification sender. There is a class called notification sender. So this notification sender class contains the send notification message. For example, public class, sorry, no, not class. We have something called send notification, and then inside here send notification, and inside here we have let's say public, and then let's say we have email notification. Okay, we have a class called email notification, and let's say we have email notification, and then what we say is notification, and here what I do is notification notification dot send something. We use it, for example, assuming that we have the email notification class available somewhere in here. For example, public class email notification. Inside this class we have a method called as the send method, public void send method, and inside here we have the code to send email notification, code to send email notification, some kind of code is here. Now the object of this class is used inside the notification sender class. Now the application is currently in agile model, and we are developing the application, and step by step currently application is containing the support for sending only email notification. But in future, that means the notification sender class is currently supporting only email notification, but in future you want to add some additional functionality to this class, that additional functionality to this class, so that it supports mobile SMS notification. And once you add that one, again a few days later you want to add additional functionality to that mobile notification sender class that sends the automatic phone call notification. I think all of you are familiar with the phone call notification. Sometimes we get an option of call me instead of an SMS kind of the, I think everyone knows that. So instead of the SMS verification, instead of the email notification, sometimes we are also provided with an option of getting a call to our mobile number from the server automatically. So the different kinds of notifications we want to. So email notification, mobile notification, and then the classic, not the email notification, not the mobile notification, the classic, the old style, manually sending the courier or the email letter, the letter to the doorstep, like the post office or something. So okay, courier notification kind of thing. So forget about whatever type of the mode of the notification is about. So currently this class is supporting the email notification, and if in future you want to keep on adding the additional type of the notification like mobile, courier, different kinds of things you want to add it, then we should not and we do not we should not and we do not want this class to be modified. It doesn't matter how many types of notifications keeps on evolving, but we should not modify this class at all. That means the problem statement here is irrespective of the type of the notifications and model of the notification that keeps on evolving, we should be able to add the functionality of the additional type of the notifications that gets evolved without modifying this one. So that's the meaning of this class. A class should be open for extension. That means we should be able to extend the functionality of this class from not limiting to email notification alone, but we should be able to extend the functionality of this class by adding to support mobile notification in future, to add the courier notification in future. So extension, open for extension, but closed for modification, which means in order to add the additional functionality like mobile notification, I should not come and type this inside this class like public mobile notification, mobile notification kind of thing. Okay, a mobile notification, let's say mobile notification, and then let's say I have another method, public void send mobile mobile notification kind of. It's not like mobile.send mobile notification dot send kind of. So it's not like this way. So it's not that if I want to add additional functionality, I want to extend the functionality, I will open up in this .java file and add additional code here, and it's not that way. So that's, it should be open for extension. If at all I want to add additional functionality, I should not modify this one, but I should add the functionality. That is the meaning of the open closed principle. The immediate clue that hits our mind, that is kind of the inheritance, which is actually not inheritance in this particular case. Okay, so the clue that hits our mind is we want to define thing like this one. So it's not 100% kind of inheritance, but what we do is we define one interface. So what I do is I will go for an interface called as the notification. I define an interface called as the notification, and inside this please ignore the typing mistakes. Okay, so public void send. So I have this notification interface, and inside this one I have the method send notification. Okay, send notification, and then what I have to do is this email notification implements what? This email notification implements notification interface, and since this is the send notification, I say, let's say this is the method that I use in here. So send notification, and this way I have this one. So here this notification sender class will no more take the email notification class here. It simply takes the notification interface name in here, and then this is how it looks. Now if you look at this entire code structure, we have the interface, we have the class, and we have the notification sender. So how do we extend the functionality of this one to support the mobile notification? We take a copy paste of this class, and then okay, and in here what I do is I take it as mobile notification. I say it here as mobile notification. So this class also implements the notification interface, and then this has the same method, and this notification can take in an object of the mobile notification, which is an implementation of the notification interface. Once again, this object can take in an object of the email notification. That means I am not touching this class at all. I am not touching this class at all, but I'm able to extend the functionality by just adding one additional class, mobile notification, courier notification, and kind of this one. So this is the meaning of open for extension but closed for modification. We will never modify, we will never open this class and modify its code, but we will be able to add additional functionality to this class without touching that one. That's the meaning of open for extension and closed for modification. I think explained it. Can you please raise your hand symbol if you understood that? Thank you all. Clear of your response. Thank you. So that's about the open for extension and closed for modification. And is it going fast or is it going slow? Is it going boring? Can someone please comment? Anyone want to comment? Going fast?
Yeah, it is going good, Ravi. Like it is not fast, it is not slow, and it is like not boring also.
Yeah, thank you, Uma. Okay. Yeah, thank you, Uma. Anyone else want to comment on that? To make some changes, to go slow or to improve even fast? Teach another way. This is all about theoretical concepts, please. No coding, nothing. The design principles is all about the best practices. We understand the problem statement and we understand what is the meaning of the how that problem statement can be fixed if you follow certain best practices like the design principles one by one, as we have been understanding. Yes, so that's about the open for extension but closed for modification, and the remaining three are pretty much easy to understand. Okay, so let's say I have the next thing that we want to understand is called the Liskov substitution principle. Okay, let's say this is the Liskov substitution principle. Okay, so this is the Liskov substitution principle. According to this principle, a child class object must be substitutable in place of a superclass object or an interface. Okay, or an interface. So once again, to recollect my core Java class when I explained, let's say we have the classes like hollow circle. Okay, we have the classes like hollow circle, and then we have the class like filled circle. First, I explained the circle example. Later, I explained the database example in core Java classes, I remember. So filled circle example is here, and then we have the class called as public class. Let's say you have something called as the patterned circle. We have something called as the patterned circle. So in these three classes, let me type in the statement of this message. Okay, so according to this principle, a child class object must be substitutable. Okay, substitutable. Okay, so irritating typing mistakes. Please ignore that. So substitutable in place of a superclass, in place of a superclass object or an interface reference. Okay, interface object reference. So this is the principle meaning is all about. So before understanding the actual meaning of this one, let's consider what happens if we don't follow this principle. And to understand this problem statement, let's say we have three different classes such as hollow circle, filled circle, and the patterned circle. And each of the respective classes will have the method like, okay, draw hollow circle. Okay, the method name is kind of the draw hollow circle, and inside the draw hollow circle we have the code to draw the circle. Okay, let's say code to draw the hollow circle. Okay, so first you understand the problem statement, and then you understand the solution and what is the principle is all about. Okay, and then you have the draw fill circle a method available, and inside here you have the method name as draw fill circle, and then code to draw the filled circle, the complete solidly filled circle with some particular color. Let's say draw fill circle, and then once again inside the pattern fill circle you have something kind of the method name is kind of the draw patterned pattern circle, draw a pattern circle, and here you have the code to draw the you have the code to draw the pattern fill cycle, vertical lines pattern, or horizontal lines pattern, or diamond lines pattern kind of. So we have three different circle classes with the respective method names and the respective code inside each class name, and that works well. Now let's say we have different types of classes available, and then you have a class called as the public class, circle main one, and inside here you have the main method, and then inside you have a circle service class, let's say public. Okay, public class you have in the circle service class you have the circle service class is there. Inside here we say circle service dot draw method is what you are currently making use of. Inside here you have something called as the circle main one and circle main two, circle main one, circle main two. Hold on a minute, sorry for the confusion. So here let's not talk about this main two once again for now. So let me first of all finish this main. So this circle main one class, it has a main method, for example, and inside the main method this is the circle service, this class which has the draw method. So what we are doing is a static method in here. So public static public, and then static void draw method is there, and this draw method makes use of an object here. So I provide here new patterned circle. I'm saying an object of the new patterned circle object is what I'm passing in here. So here this new patterned circle is an object. So here, because I'm passing inside a patterned object, so I should declare here patterned circle C, patterned circle C, and inside here, or should I say draw C dot draw patterned circle, C dot draw pattern circle. Some code is there, forget about the names and all. So we have the circle service which has the static draw method, and the draw method is taking a parameter of the pattern circle C object and C dot, and this since this C is a pattern circle and the method name of the pattern circle is draw pattern circle, I'm able to do this one, and this is the case. And I have these cases like draw main one, draw main two, draw main three, kind of multiple objects classes are there where I'm making. Now in this entire story, what is happening is this circle main one, circle main 2, 3, 4, 5, 600, all of them are currently making use of the new pattern circle. And as my project evolves in future, my business requirement changes, and it demands me, no, I don't want the pattern circle this time, I want solid circle. So if I want this one to support me the printing of the solid circle, what I want to do is I have to go and change in here. What is that? New filled circle, new filled circle in here. So here also I want to make a change to this new filled circle. So the focus is not on here, please forget about this main one and two. New filled circle is what I want to do, for example. So if I want to make a change here, new filled circle, but here the draw method of the circle service is currently supporting the pattern circle, and the filled circle is incompatible. So this C object C cannot capture a filled circle, because this is a pattern circle PC, for example. This is a pattern circle PC, for example. So if I want to provide this one, this won't support me. So I will have to change this one as well, like filled circle. I will have to change this one to filled circle, and then this becomes filled circle FC, and this becomes filled circle FC. So as my business requirement changes, I should come and change this one. I should come and change this one. And future, I want to change filled circle to hollow circle. Again, I have to, as my business requirement changes here, I will have to go for and then make a change to hollow circle in here and here. Okay, hollow circle kind of thing. So every time the business requirement changes, I should have to I will have to come back to this particular draw method, change its method name, change its interface class name, as well as the respectively the method name. So if I change this one to hollow circle, I will have to change this one to hollow circle. Okay, I will have to change this one to hollow circle. So if I change this one to filled circle, I will have to change this one to filled circle and this one. So as long as as on every time the requirement changes, I have to make changes, here as well as here. Why? Because the hollow circle methods classes method name is hollow circle, and the filled circle classes method name is filled circle, and likewise. So every time I change the class name here, because I want a different type of the circle to be printed, I have to change this one here. Consider there are 100 circle service classes, circle service 1, 2, 3, 4, 5, 6, and 100 places, and I will have to change this one in here and this one in here across 100 occurrences of the different service classes. So that is the trouble. So how do you solve this problem is like, see, whatever object I supply in here, this whatever I object supply in here, this should be substitutable to this one, substitutable to this. So here, whatever class I mentioned, it should be capable of consuming an object of its children of any kind. Okay, so that is the meaning is all about the Liskov substitution principle, wherein the according to this principle, a child class object must be substitutable in place of the superclass object or an interface. To fix this one, what I want to do is I will take an interface in here, let's say public. Okay, public interface circle, public interface circle, and what I do here is I provide a method, public void draw method, public void draw method, and inside the draw method, this is because an interface is an abstract. This is an abstract method, and I force these interfaces classes to implement the circle interface, implement circle, and then I take implement circle across the circle classes, kind of this one, and once again kind of this one, kind of this one. So when a class implements an interface, the rule number one is that class has to override the methods of the class. That means this class is now forced to use the method of this class, exactly the same thing. It is no more allowed to use its own method name. Okay, the method name has to be same across the now this is the case. Now here once again the method name cannot be of its own, and the method name cannot be of its own in all across the places. Now what will happen is all the classes are now forced to use the method name that the interface is demanding, and then all of them are using the same method name but a different logic inside them. So this is what is called a polymorphism. And when I do this one inside here, inside the circle service, what I can do, I can just supply the interface name circle C, and then inside this one, this time I don't have to bear the headache of different type of the method names. Whether what type of an object is passed, the method name is always fixed, draw. That's all. So it's always draw method name, and it's the interface name. Now here I can change this one to hollow circle, I can change this one to filled circle, I can change this one to pattern circle. So here this is substitutable, substitutable for this object reference of the interface. So this is all about the problem statement and solution and the benefit of the Liskov substitution principle. I think I completed that. Can all of you please raise your hand symbol if you understood this problem statement along with explanation and meaning? Yes, thank you all. Clear of your response. So that's about the Liskov substitution principle, and then the next thing of interest is something called as the interface segregation principle. This is also something kind of similar to the circle concept, but slightly different. Now the next principle of the solid design principles is something called as the interface segregation principle. So let's say if I talk about this one, interface segregation principle. Now if you, let's say you have as per the interface segregation principle, a client of an interface interface should not be forced to implement unwanted methods. A client of an interface should not be forced to implement unwanted methods. Client means the class that implements an interface. For example, this is the class, and this is the interface, and this is the class that is implementing this interface. So this class that implements this interface, I'm calling it as a client. If you look at this one, so a client of an interface should not be forced to implement unwanted unwanted methods. If you're worried or confused with the word client, I can say a class. I can use the straightforward. This looks little, a polished word for me. That's the reason I used it. If you are bothered, I can make it a class that implements an interface. A class that implements an interface should not be forced to implement or to override unwanted methods. To understand this sentence, which is as simple, but let me explain that one. For example, we have an interface class. We have an interface called shape. Inside the shape interface, we have the methods like void. Draw rectangle is there, and then you have the void. You have the draw circle is there, and then you have the void draw triangle is there. Okay, you have the draw triangle is there, and then you have the void draw square is there, and then draw the square. So this interface shape, which has the various methods available, and let's say there is a class that wants to make a functionality to the circle method of the interface, and then let's say we have the class like public class. Okay, let's say circle shape implements, let's say you have something called as the implements shape interface. Now this circle shape class, the goal for me to declare and define this circle shape class is to provide the functionality to the draw circle method that is defined inside this one. But as per the rules of the interface, if a class implements an interface, that class is definitely has to override all the methods, or otherwise it has to declare them as public, abstract methods kind of thing. So in this case, this class, if it is implementing this interface, this class, as the name of the class defines, which is pretty much meaningful, this implies this is its only purpose is to provide the functionality of drawing a circle. And then so this method has been implemented in here. For example, public void draw circle, and then the code is there. Okay, so I have the code. Let's say system.out.println. Okay, circle circle is drawn, and some code to draw the circle is there. But so this is the actual code that this class wants to provide to implement this interface. But in this case, this is providing. But here, even though this circle shape class is not interested, it's not interested at the same time. It does not bother to want that even though not required, the circle shape class is forced to implement all these methods. So what the circle shape class now do is public void draw rectangles. It leaves the implementation empty. So public void let's say draw triangle, and then it leaves the methods empty like this one, because as per the rules of the interface, a class that implements an interface. Okay, so that makes kind of, so this is forced. Okay, so in this case, what will happen is, even though not required, this is compelled to implement the unwanted methods, which is embarrassing. Okay, so that's the problem statement. That is the interface segregation principle. What it says is, in order to overcome this problem statement, so this problem statement is answered by this principle, that is the interface segregation principle. Separate all the methods into the respective interfaces, and so that the callers of that interface, the clients of that interface, are not forced or compelled to implement. So the fix to this problem is kind of, we have 4 interfaces. Okay, so public interface, public interface circle is one interface. Inside here you have a method public void draw circle. Okay, public void, please ignore the typing mistake. You have an interface circle, and then you have an interface rectangle. Okay, you have an interface rectangle, and then the method name is draw rectangle, and you have an interface kind of the triangle. Okay, you have an interface kind of the triangle, and then this is okay, triangle in draw triangle method. Okay, and then you have an interface kind of square. Okay, So an interface should contain only those methods which are actually required the purpose of the interface. So that's it. Now interface segregation. We have now segregated all of the methods of the interface into multiple interfaces. Now, if any client wants to make an interface implementation, they'll take only but that particular interface, and they are required to implement only that particular method. They are not at all compelled to override all the methods which are actually unwanted. That's the meaning, which is the best way to maintain an application's code whenever we want to. So that's the interface segregation principle. Please, can you please raise your hand symbol? You understood the problem statement along with solution and meaning of the this one. Yes, thank you all. Clear of your response. And last one is the dependency principle. Okay, dependency abstraction. This is about the dependency injection that you already understood in Spring Framework. Okay, so as per this definition, the statement of depend on abstraction, not on concretion, not on concretion. For example, to understand this one, you have, let's say, public class, student service or customer service or employee service classes there, and inside here this let's say you have two classes like public class, student, Oracle DAO, student Oracle DAO implements student DAO interfaces in here. Okay, and then you have public class student MySQL DAO implements student DAO interface is still there. And then let's say there are two classes. This class contains the code, JDBC code or Hibernate code, doesn't matter. The code that connects to Oracle database, and this class contains the code that connects to the MySQL database and some other code that connects to MongoDB database, and likewise. All these classes are there. And then so this one, inside this one, if you, let's say you have something called the student Oracle DAO, you make use of this one, and student service 1, student service 2, student service 3, multiple things are there. And then this is the class name that we are declaring here. If at all in future you want to switch to MySQL DAO, we have to change in here MySQL DAO. And once again, do not think about this single class, think in bulk. So when you want to switch from Oracle DAO to MySQL DAO, you have to go and make changes across places. Okay, go and make changes across places, MySQL DAO. And again, you want to switch to Oracle DAO, you have to go and changes across places. So to overcome this problem, what we do is, instead of declaring on the concrete class name, we depend on the interface name. When we depend on the interface name, during runtime, that's kind of the Spring Boot container or Spring container. During runtime, we provide a class of either the Oracle DAO, or we provide either the class of the MySQL DAO. So that is the meaning of depend on abstraction. This is the abstraction, and this is the concretion. Like this is kind of the depend on abstraction. This is the simple thing. This is a known topic to all of you because I explained you in the Spring dependency injection concept and its loose coupling topic and all that stuff. So all of you, please raise your hand symbol whether you understood the dependency abstraction concept.
Ravi, if you don't mind, please explain it again.
Sure, thank you. So here, if you don't make use of the interface name, let's say you are currently making use of the student Oracle DAO class is there, student Oracle DAO class is there, and the student service 1 class is there, and then let's say call a student 1 service 2, 1 service 3, 4, 5, 6, 7, 8. Okay, you have 10 service classes like this one. And then in future, all these classes are currently depending on what it's a class name, right? It's a class name. And if at all you want to supply a different object here, if at all you want to supply a different object here, for example, you have a new student Oracle DAO class is there, and you have this kind of code across multiple service classes, and then like this you have multiple classes are there. In future you want to switch to MySQL DAO, you have to make change here, you have to make change here, you have to make change in here, because because you have to make change here, here. So across places you have to change. You're depending on the concrete class. Concrete class means non-abstract class here. So if your object type is of belongs to a specific class name, you have to, and when you want to switch from one class to other class, you have to make changes across multiple locations. This is called the tight coupling. But rather, if this one is provided during runtime using the Spring topics such as dependency injection, like setter injection kind of thing, whenever you want to change it, you will go and change in the XML configuration file, or you will go and change in the @bean or @configuration file in Spring. Okay, so where you have to change. So this is loosely coupled. So this kind of if you change this one to just an interface name, if you change this one to an interface name and don't use the object creation code in here, and this will come and use the object creation code in here, and you will use the object creation code in here, and you have the setter method. So public void set DAO is there, and student DAO is there, and then inside here you provide a setter method. This dot DAO is equal to DAO in here, and then you have this set DAO method. The object to the DAO interface, the object that we pass inside this DAO can be, because this is an abstract class, right? Abstract object. This is not concrete. So if this is abstract, I can pass inside any concrete implementation. Sometimes I can pass inside this DAO Oracle DAO, and sometimes I can pass inside this DAO MySQL DAO. So dynamically I can change whatever I want using the Spring container kind of thing. Alfia, did I explain you clear now?
Yes, it's clear now.
Thank you. All of you, please raise your hand symbol if you understood this entire design principles, concepts. Anything to say? Anyone want to say speed, regarding speed or the core and that? Yeah. That's it for now. We'll connect again based on my next communication in the WhatsApp group. Okay, so thank you all. I will stay back in the